Hello, anybody here from JSS IT team?
Sir, this is Juby. Good morning, sir. I'll find it out, sir. I'll find it out.
The YouTube streaming has not started. Already we are 15 minutes late.
Yeah, sir. I'll
Pratish sir?
Yes, sir.
Sir, within 2 minutes they told. So now they are working, sir. Within 2 minutes it will be started.
Okay, let's see.
Sir, now it's okay, sir?
Yes, sir, it is live.
Yes, madam. It is started. You can start, madam.
Yeah, it is live now. Shall we can start.
We can start. Okay. Good morning, everyone. Thank you for joining us today. Our sincerest apologies. There were some technical difficulties, so there was a delay. Thank you for your patience. So thank you for joining us for our today's session of Indian webinar series, Introduction to Computational Drug Design, co-organized by Schrodinger and PCI. I take a moment to thank our collaborators for supporting this event. Today we have another demo session on 1D, 2D QSAR model building using AutoQSAR. So without further ado, I'd like to welcome our today's speaker, Dr. Pritesh.
Thanks, Sylvia. Do you see my screen?
Yes.
Great. Okay. Thanks again for your patience. Sorry for making you wait. So there were some technical issues. Now everything is fine. So let's continue our discussion. So today in my session, I would be talking on 1D and 2D QSAR, so followed by AutoQSAR. So in continuation with yesterday's discussion, my colleague Dr. Vinod discussed on how you can develop 3D QSAR. So he discussed about field-based QSAR as well as atom-based QSAR in yesterday's session. So in case of 1D QSAR and 2D QSAR also, the principles would be same. So you have to represent the structure in the form of descriptor. So then you try to generate a statistical correlation or statistical model to find what could be the biology activity. Okay, so the dependent variable here would be biological activity if you are going with QSAR, quantitative structure activity relationship, or if you are looking for property, so various property also you can find out. So in that case, the dependent variable would be the defined property. So these properties could be melting point, log P, or it could be even toxicity models. So for example, like liver toxicity, ototoxicity, or audio toxicity, or genotoxicity. So depending on whether it is activity or property, you can either go with QSAR or QSPR. So the way you represent the molecule, based on that, we consider what is the dimensionality of the QSAR. For example, if you represent the molecule with the normal physicochemical properties. So for example, let us say you are using either log P value or molecular weight or acceptor or donor. So these are all the numbers. So structures we cannot use for generating equations, right? So structure we have to convert in the form of number. So here to convert the structure, if we use the descriptors which are physicochemical properties, like what I mentioned, log P value or molecular weight, acceptor, donor, these type of properties. Now these are numbers which are directly dependent on the structure. So we can use these numbers instead of the structure, and with that we can try to generate a statistical model. Now, if you use physicochemical properties as a descriptor, by seeing these property, you will not get a hint about the structure of the molecule. By seeing molecular weight, you cannot predict what could be the structure of molecule, or by seeing number of acceptor or donor, you cannot say what could be the structure of molecule, right? So that is why if you use these type of descriptor where it doesn't give information on the structural features of molecule, we call it as 1D QSAR. So for generating the descriptor, if you use topological descriptors, now topological descriptors will give you information on the connectivity between two atoms, right? So in such cases, we are representing molecule in 2D, like when you are sketching a molecule on a paper. So how you represent? You mentioned the connectivity, right? So if you use topological descriptors or fingerprint descriptors, now these would give you information on 2D representation of the molecule. So that is why we call it as 2D QSAR. So generally, when you go for QSAR, you would prefer to go with the 3D representation of molecule. Like yesterday you discussed, for the lead modification, you can use field-based or atom-based QSAR. So in case of property prediction, generally we prefer to go with 1D or 2D QSAR, because any property is not much dependent on interaction or 3D structure. It is more of a general statistical correlation we are trying to generate here. Okay, so let us see into the details. So how we can generate the descriptors, or what are the methods available to generate the various types of descriptor, and how you can generate 1D, 2D QSAR, and then we will also have a discussion on what is AutoQSAR, or how it is useful, what is the benefit of going with AutoQSAR. For generating 1D or 2D QSAR, you have to go into Canvas. Canvas is the module which you will have to use in Schrodinger. So Mastro is not the interface here. The interface what you use is Canvas. So this is how the Canvas appears. Sylvia, can you confirm, is my interface appearing fine?
I can see your interface, yes.
Okay, great. So let me Okay. Yes, thank you. So here the interface again is almost equivalent to what we earlier saw in Mastro. So same type of tools we have. So we have here various menu options. So like file option where you have option to save the project or import or export the molecule, or edit option or viewing options. So applications will have all the list of the applications. Okay, so here you have option to generate either molecular features, or you want to go with whichever type of statistical model you want to generate, whether it is MLR, whether it is PLS. All those applications you would be able to access either to application, or you can go through task menu. Okay, so let me import few molecules. So you can go to file and import structure you can use to import the molecule. So I have here a set of molecule, about 35 molecule collection I have, which I have run already the LigPrep. So prepared molecule I'm using here. So I'll just import this molecule. So when you import the molecule in Canvas, you have an option. So it will check for a duplicate and all. So if there is any duplicate structure, it would remove. So the moment you import, you would be able to see all the molecules. So here we can see, so and the activity in the logarithmic scale, that is PIC 50, we have already we have here in the table. So yesterday Dr. Vinod explained you how to convert the activity, the decimal number, into logarithmic scale. So same the same way we have converted here. There are a few extra columns. Just to avoid the confusion, I am deleting this. So what we need here is the structure of the molecule, based on which we will be generating the descriptor and the activity property of the molecule. So here I am basically generating QSAR because I am trying to generate a correlation between activity of molecule with the structure. Okay, so the first thing is I have to generate the descriptors. So to generate the descriptors, you have to go to applications. So in applications, you have molecular property, right? So in application, you have molecular property. So here various type of properties or descriptors you would be able to generate. So if you click on that, you would be able to see here there is an option for generating physicochemical descriptors, or topological descriptors, or lit filter descriptors, or our normal quick prop descriptors also available here. So let us go with one by one. So the first one is physicochemical descriptors. So here you can see all the list of physicochemical descriptors. So further, I would also recommend you also activate MolCon descriptor. So total of about 250 types of descriptors are there here in physicochemical descriptors. So you can activate here calculate physicochemical descriptor. So if you activate this option, then all the option will get activated. Further, we will also activate, will generate the topological descriptors, right? So topological descriptor, so you have to activate here calculate topological descriptor, and then these are all the different descriptors. So you can say add all, so that all these descriptors will be calculated. Okay, so with that, I wouldn't be generating lit filter and quick prop descriptor, just to save the time. So just click on compute. So what I did, I just clicked on the compute button. Here below you can see the compute button. If you click, then the job would be launched. So here in this area of Canvas, you would be able to see in the message view, you would be able to see the status of the job. And further, if you go to the project view, on the right side corner, there is a column you can see, which is called as project view. So in the project view, you would be able to see the status of the job. So whether the job is completed, or whether it has been incorporated, all these details you would be able to see here. So here we can see these are quite fast jobs. So you can see the physicochemical descriptor has been already generated. So it is saying the descriptor has been generated. So you can right click and you can say incorporate, so that the generated descriptors will be added to the table. So once the table gets filled up, you can see here the rows and column numbers will increase. So here you can see, I hope you are able to see my cursor. So on the down right side corner, there is a statement which says what is the total number of rows and column available, how many are visible, that means how many are displayed, how many are selected, right? So selection is like if you click on and which appears like either gray color highlight, then that is called as selection. So you can see here, if I select one, then it says one is selected. Okay, so we need all of them, so I would be selecting everything. So you can see now the number of columns are 367. So 367 types of descriptor has been added. So that is only the physicochemical descriptor and mole-count descriptors. Now I will also include the topological descriptor. So here you can see the job has been completed. So if I click incorporate, then even the topological descriptors will get added. So you can see here total now we have about 600 odd descriptors generated. So now these 600 descriptors we can use for generating the QSAR. Now if you observe here, for some of the columns, for some of the ligands are continuously remaining same number. It is not it is not changing. So these type of descriptor, if we use, that will not give us really any much information. So this is of no use for us. So we need to identify those type of descriptor which continuously change with the structure. If the descriptor value changes, then that would be informative for us while generating the model. So now what we will do, from these 600 or about 591 descriptors, whatever we have here, we will try to identify those descriptors which are continuously varying or which are changing. So for that, we have a nice application in Schrodinger canvas called as feature selection. So it calculates the variance for every descriptor, and based on the variance, the descriptor which is continuously changing for every molecule. So those features or important features only it will pick up. So let me show you. So you have to go to applications. In applications, you have feature selection. So click on the feature selection. So here I do not want to delete the activity column, so I'm removing that. So rest all the descriptor I'm considering here, about 590 descriptors are there now. So just go with the default option, nothing need to be changed here. Click compute. So quickly it will calculate. So here we can see the status. So it has completed already. So now you can say right click on the completed job and you can say view. So it is saying out of out of about 6 or 590 descriptors, 18 descriptors are very important and having variance. So you can see here average variance is like 70%, 79%. So we will use only these descriptors because these 18 descriptors are continuously changing. Okay, so we can check here the variance plot. So whether whatever 18 descriptors we are selecting, is that more than sufficient, or should we increase the number of descriptors to be considered? So to check that, you can go with the variance plot. So if you click on variance plot, you can see here. So the blue color graph, whatever you are seeing, this was the original number, and the red one is the reduced number. So you can see here, so whatever in the flat area, whatever the straight line, whatever you are seeing, this is of no use because here the variance is not changing. So value is remaining same for all those descriptors. So here you can see only we have picked now in the red line those descriptors which are continuously changing. Only those descriptors we have picked now, and it is reaching up to the blue line. So this says whatever descriptor we have considered here is more than sufficient. So you can click here on the filter master view so that only those important 18 descriptors would be visible, and rest all descriptor it will hide. So if you click on here filter master view, now you can see. So here you can see now total out of 589 columns, only 20 columns are visible now. Rest all column it has hidden. So 18 are these descriptors. So here we have 18 descriptors, and one is for the structure and one is for the activity. So another 18 structure. So total it would be 20 column we will have here. Okay. So now you can see all the numbers are continuously changing. So whatever number we are considering, it would be able to, or whatever descriptor we have shortlisted are really important descriptor which will give us maximum information about the structure. So these descriptors would be really helpful for us in generating a meaningful model. Okay, so let us go with the first type of model generation. So the most simplest one we generally go with is multiple linear regression analysis, MLR. Okay, so in the MLR statistics, so here either univariate equation or multivariate equations you would be able to generate. So to access MLR, you can click on MLR. So this is how the panel appears. So here you are specifying here which are the data set you are using. So all the molecule which we have displayed, so all the 36 molecules we are considering, and the 20 descriptors, which I mean 20 column, one is for structure and one is for activity. So these visible rows we will be considering for generating the equation. So we will go with, since we have to generate the model, so make sure you have opted the build model option here. And then the Y variable, the dependent variable is activity. So that is what you have to check here. And these are all the rest of the descriptors. So you can add all. So here, if you go with the normal option, so if you go with the build model from selected X variable, that means all the 18 descriptor it will use. So if we use so many descriptor, it becomes really complicated. So while selecting the molecule, it becomes really complex. So rather, let us select out of these 18 descriptor, which are the most important descriptor having influence on the biological activity. So we will generate a multivariate equation with lesser number of X variables. So if you go with the second option, choose best subset, then it will identify the descriptor which is having maximum influence on the biology activity. So you can go to the option and you can specify here how many variables you want to consider. So by default, the first option is 1. That means it will generate univariate equation. So univariate equation will have equation something like y is equal to mx plus c. So x will be variable. So out of 18 variable, only one variable it will consider. So it will give you a straight line correlation, right? So generally the biology activity is dependent on multiple variables. So it is never dependent on only single variable. So always it is advised to increase the variable. So I'll put here 5 variables. Okay, so just click OK. Now you can go to the second tab here. So you have to define training set and test set division here, so that you can validate the generated equation, whether the generated equation is a meaningful equation, or it is just a chance correlation, or it is a true correlation, or whether it is able to predict the activity for the population. That is what you, if you want to check that, for that you have to go for validation. So that is why we have to divide the molecule into training set and test set molecule. So yesterday we know the nicely explained you the concept of validating the QSAR. So how you have to divide the molecules into training set and test set, what all the precautions you should keep in mind, all those things he has nicely explained. So please refer yesterday's video if you want to get more details on understanding about the validation protocol. So here I will put about 70% of the molecule in the training set, and with the seed. So whatever seed you consider here, for that seed, the training set test set combination remains same. So you can, if you change the seed, then the training set test set combination changes. So if you click on apply button, you can see certain it will change the label. So if I again change here the generate seed, again the combination of training set test set changes. So like this. So for a particular seed number, always the training set and test set combination remains same. See, if I click apply button even multiple times, if I click, it doesn't change. But if I change the seed number, then the combination changes, right? So always remember, if you want to retain or if you want to remember what is the training set test and test set combination you had considered, if you remember the seed number, then you should be able to get back the combination. Okay, so unless you manually don't change anything. So if you manually change, then the seed will not be able to remember anything, seed number. If you go with the automated method, then only you would be able to retrieve back. Okay, when you are going with the automated method of generating combination of training set and test set, in such scenario, it doesn't consider any diversity. So either structure diversity or activity diversity, all these features it won't really consider. It randomly assigns some molecule into test set and some molecule into training set. Okay, so generally why we are going here with the random set combination? So Canvas is designed to handle a huge number of data set. Okay, so here I am considering only example case. So quickly I wanted to show you. So demonstration I have to finish in certain time, right? So that's why I took only small set of molecule, only 36 molecule I considered. But when actually you are going for model generation in Canvas, you can consider thousands of molecules. So it is capable of handling a large data set. So in such cases, manual assignment of training set and test set is very difficult. So when you have thousands of molecule, let's say 20,000 molecule, 40,000 molecule, or 1 lakh molecule, if I have in my hand, then in such cases, dividing molecule into training set and test set becomes very difficult. So in such scenario, we go with the random set of assignment. Okay, so when you go with that, so if you remember the seed number, then you would be able to recall which molecule or which of the set, which molecule you had assigned into test set and which molecule you had assigned into training set. Getting this information becomes handy, or which becomes very simple. Okay, so now I have already assigned the training set and test set. Now you can click on build model option. So you can see here there is a build model option. So if you click on build model, very quickly, it's very fast, it will generate the model. So you can see here all the coefficients and the descriptors. Okay, even y-intercept you can see. So it is something like y is equal to ax plus by plus cz, like that type of equation, multivariate equation. So all the descriptors you can see here, and their corresponding coefficients also you can see here. And here you can see the statistical parameter. So correlation coefficient or variance or probability of error, sorry, standard deviation, the statistical parameter calculated for training set and test set, you would be able to check here. Okay, so the equation which shows very good statistical parameter for both training set as well as test set can be considered as a good equation. Now again, to get these details, you can refer yesterday's video from Vinod, who has really very nicely explained what are the required numbers and how should be the equation. So for an acceptable equation, I would say standard deviation should be close to 0, R square should be above 0.9. Okay, when you have a small set of molecules. So here we have only 36 molecules. In such scenario, we want to have R square value above 0.9. So F value should be as large as possible, variance should be as large as possible, and the probability of error should be as small as possible. In case of test set molecule, the RMSE, it is analogous to standard deviation of training set. So RMSE should be close to 0. Q square is the correlation coefficient between the actual activity and the predicted activity for the test set molecule. So here R square is the correlation coefficient between the actual activity between the training set and the predicted activity of training set molecule. So this is for the test set molecule. The Q square, the difference between the R square and Q square should not be more than 0.3 for acceptable equation. And the Pearson R tells you whether the correlation what you are observing here is a chance correlation or a true correlation. So this uses a leave one out method here while generating this correlation. So the difference between Q square and Pearson R should not be again more than 0.3. So if you see here, the current equation, whatever I have generated, is not really a good equation. So in such scenario, you can again change the seed, and you can change the combination of training set, test set, and just click the build model. So it will ask, do you want to overwrite the job? So you can see here the job name. So it has given MLR_01 as the name. So I'll just say yes, because the earlier equation was not good. So here you can see again, if I see the equation again, it has become bad. So like that, till you get the meaningful equation, you have to keep on trying. Okay, so the QSAR model generation is a tricky thing. You need to really spend a good amount of time so that you get a satisfactory model. Okay, so you may have to try 100 times, maybe 500 times, or more than that. So this is a time consuming thing. So you have to patiently work until you get a satisfactory satisfactory model. You have to keep on generating the model. Okay, so let us imagine, again, this is a worst equation. Q square in minus direction is not at all acceptable. Let us imagine this is a good equation, even though this is very worst, very bad equation. Let us imagine this is a good equation. So further, you can export the model. Okay, you can export the model. So the model would be saved with the extension of MLR, like Word document. When you export, it will save it in DOC. So here it will have .mlr as the extension. And also here you would be able to see in the project view, whatever the runs you had finished, you would be able to see the list of that. Like here you can see, right, physicochemical descriptor, the run we had generated. So same way here you would be able to see the project layout. Okay, further you can also generate a scatter plot. So if you click on the scatter plot, it will ask you to plot whether you want to go only with training set or test set, or all the molecules you want to consider, you can specify here. So I'm considering both of them. So training set will be shown with the red color dot, and the test set molecule would be shown with the blue color dot, which when you click plot, you would be able to see the equation. So this is a bad equation we saw already. The equation statistics was really bad. So that is what you can see. Otherwise, all the dots should be falling very close to the line. Okay, so this you can save. So you can go to file, and save image option is there, which you can put in your publication. Okay, so this is how you can generate multivariate equation. So here I was showing you earlier, since the panel was already open, I was not able to expand here. So here you can see. So if you again here, if you say view, if you right click and if you say view, then the same equation, whatever you had generated earlier, you would be able to check. Now you can see it will have a different name. So again, you can change the test set, the seed you can change, and you can continue generating the new model. And what is the statistics you can check here. So once you generate the model, you can go to the options again, and here you can apply the generated model. So either the previously generated models you can consider, which is there in the list. So either whichever model you want to consider, that you can consider, or you can go with the imported model. So MLR model you would be able to import. So I had generated it on PCI. So oops, I did not export it, right? So that is why we don't have it. So if you export here, so export model, if you do it, so earlier I did not export it, so that is why we are not having that option. So if you had already generated equation, then you can import it and you can apply it. So certain columns, so whichever new molecule you can import it, first you have to generate all these descriptors, and then you can apply the generated model to predict the activity. The next tool I would like to show you is the fingerprint based calculations. Okay, so here in case of MLR, we went with the molecular property. So either physicochemical property or topological descriptors or Lick filter descriptors or quick prop descriptors we consider. Instead of that, if you want to consider the fingerprints, binary fingerprints. Okay, what is binary fingerprints? Binary fingerprints are the representation of the 2D structure. So it will so here we follow some certain rule based empirical formula, where we will check whether particular rule is followed or not. Like for example, let us consider in a simple way, let me tell you. So is there a halogen in the molecule? So if it is there in the structure, it will put as 1. If it is not there, it will put as a 0. So this is the binary, right? Zeros and ones. So if the rule is followed, it will put as 1. If it is not there, then it will put as 0. So whole of this binary string we will use, and we will compare these string across the different molecule to compare them. So that is how the binary fingerprints works. There are various ways with which you can generate the fingerprint. So you can go to applications and you can, okay, let me again show you how to access or how to generate binary fingerprints. So you can go to the application, and here you have binary fingerprints option. So if you click here, you can see there are various methodology, about 7 types of fingerprints methodology you have here. So linear, radial, dendritic. So these are the ways which expresses the molecular connectivity. So if you have linear molecule, then if you go with linear fingerprint methodology, it gives you a better expression. If molecule have a lot of like small branches and all, then radial would be much better. If lot of branching substitutions are there, in such cases you can go with dendritic. Like that, you can check various one. So I will currently go with the dendritic fingerprint. So you can see the whichever method you use, the name here changes. So you can try various types of fingerprint methodology. Again, this is the research. You have to try out which fingerprints really works out best for you, which one is most suitable. You have to explore. So it is your logic. So with that, you just select the fingerprint and click create. So here you just click OK. So once the fingerprint generation starts, you can see here the status, right? So it's saying it has done. So I can say incorporate. So even though it generates in the background the long string, but while incorporating here, it will represent it in a single column. Okay, so don't get confused here. Only one column will appear here. Okay, now we will use this fingerprint for generating the QSAR. So for generating the fingerprints, so we can go with the principal component analysis. So how do you decide on whether you have to go with multilinear regression or principal component analysis? When you have small number of descriptors, so multiple linear regression would be able to handle the situation. So it would be able to take care of like descriptor selection. So earlier we saw, even though we had 400 descriptor, we reduced it to 18 descriptors. So the one which are having maximum influence, only that we considered. So when the number of descriptors are small or in number, small in numbers, okay, so in such cases you can go with the multilinear regression methods of statistics. When the descriptor is huge in number, so yesterday we came across 3D QSAR. So there we send different probe atoms to identify the field. So in such cases, the number of descriptors generated would be huge. It would be in lakhs together. So in such cases, the multilinear regression statistical methodology will not be able to handle it. So in such cases, we go with principal component analysis. So in case of fingerprints also, we will have very large number of strings. So multilinear regression may not be able to handle it. So in such cases, you can go with principal component analysis. So here, here again, you can consider the either even the properties you can consider, or fingerprints you can consider. Okay, so oops. Okay, fingerprint column we can specify here, and we have to generate here separately the training set and test set. So that is how we have to generate, rather going with the, oops, sorry, this is the wrong panel. This is a principal component analysis. Sorry for confusion. So here we have to go with, I'm really sorry for confusion. We have to go with partial least square regression analysis, PLS statistics. So here you have to go to applications, and in the partial least square regression, you can open the panel. The panel exactly appears same thing like MLR. I'm really sorry for confusion. So the way you generate the model in multilinear regression equation, the same way here also you can generate. So so here you define the y variable, that is activity. So for y variable, we have all the different variables. So you can consider here all the X variables. So including the fingerprints also you can consider here. You can just click add and you can go to training set, and you can change here the set training set test set combination. So you can generate a seed, and if you click apply button, then the molecule will be divided into training set and test set combination, and then you can click build to generate the model. So here in the option you can increase the PLS factor. So yesterday Vinod explained you about the PLS factor. So how to decide on the maximum number of PLS factor which you can consider. So generally we follow a rule, that is the number of molecules in the training set molecule divided by 5 could be the maximum PLS factor you can specify. So here in our case we had about total 36 molecules. So I had put about 70% molecule in the training set. So that means about 25 molecule would be in the training set. So 25 divided by 5 will be the PLS factor, that is 5. So that is why I have put 5. So 5 is also a large number, but still we will try out. So with that, if you click build model, then you would be able to generate the model. So for each PLS factor it will generate. So you can check here the statistics. You can compare it across training set and test set, and you can check whether the generated model is a good model or bad model. Further, we can go with the method called as KPLS, kernel based PLS regression. So here you can use the since you are using PLS, it generates the contours. So yesterday when we were discussing about 3D QSAR, you could see the different contours, the acceptor and donor contours, or hydrophobic contours, or electrostatic contours. Those things we could see. Similar type of contours we would be able to generate. So this is the only tool with the 2D QSAR which is able to generate the contours. Okay, so you have to go to applications. In the applications, you have kernel based PLS regression, KPLS. So here you again, the panel everywhere appears same because the methodology is same. Okay, only the descriptor what you choose or the statistical method what you choose would be different. Okay, so here you can choose the fingerprint column. We have already generated the dendritic fingerprint. Even if you want to consider the property, that also you can include, but I won't be including those. I would like to go only based on fingerprint column. So here again we will increase the PLS factor. So the same molecule set we are using, so up to 5 PLS factor I will consider. So then you can go to training set test set definition. So oops, I have to reduce here to 70%, and then if I click generate seed, and if I click apply button, the molecule would be divided into training set and test set, and now you can click build model. So quickly it generates. So here you can see the statistics for training set and test set, and based on the statistics generated, you would be able to decide on whether the generated model is a good model or bad model. So here again, you would be able to generate a scatter plot. So this model looks pretty decent. So we should be getting still there is some deviation because the statistics was not really very great. It was 0.7 it was showing, right? So you can see here, but training set is showing very close, very good prediction. Okay, so further, see here you can see 0.7. So this is not, sorry, 0.3. It is not really a good equation. So here if you see it is coming 0.99. So for acceptable equation, it should be within the difference between the R square and Q square should be within 0.3 I mentioned. So this is really a bad equation. So again, you have to generate. Okay, let us imagine this equation is a good equation. So let us go for the visualization of the model. So if you see here, there is a visualize model option is there. So if you click on this, so now you would be able to see the contours like this. Okay, so for all the molecule, it would show you which portion of the molecule is positively contributing for the activity, and which portion of the molecule which is negatively contributing for the molecule. So by default, if you see, the blue color is blue color highlights the portion of molecule which is having detrimental effect on the molecule, and the red color represents the portion of molecule which is having positive influence on the molecule. If you don't like this color combination, you can change it. So let's, for example, so if you click on the minimum button, I can change it. So generally we show it in green color, the one, the red color, the one which is having detrimental effect. That is what I'll do. So I'll go with the red color for having detrimental effect, and the portion of molecule which is having maximum or better or the positive contributor, that I would represent in the green color. So here from the coloring panel, you can choose it. So now you can see the portion of molecule having positive influence will be shown with the green color. So you can see in the most active molecule, you will see a lot of green color because that is a better molecule, right? So you can see the bad molecule showing a lot of red color tinges, right? So further, now you can use this information for designing the new molecule. Okay, so if you double click on a molecule, now let's say this is the molecule which I want to further modify. Okay, so just double click on this. So it will open it in a new panel where you get the option to edit the structure. So click on edit structure. So the 2D sketcher will open. So here you just bring out some modification. Let's say I want to put a OH group. Okay, something like this. So just sketch the molecule, whatever modification you want to make it, just bring out here and just click OK. So immediately for the new molecule, it will apply the model and it will predict the activity. You can see. So initial activity was like earlier, before the modification, it was 5.4. Now after modification, it is saying the activity of molecule is increasing. So if you feel this is a meaningful molecule, if this is a so if you are satisfied with this, then you can add it to save to the project table, and you can consider it for further study. So this is how you can use this information. So this is the only statistical method using which you would be able to generate the contour. Okay, so similarly, now all these methods are linear statistics. So I discussed about MLR or PLS or KPLS or principal component analysis. These are all the linear statistical methods. So that means either the descriptor will have a positive influence, or it will have a negative influence. So if the descriptor value increases, the biology activity will also either linearly increase or decrease. Okay. So most of the time biology activity doesn't happen like that. So it will have a categorical order, or it would be non-linear. So up to certain, so let's say if you increase let's say size of the molecule up to certain range or up to certain number, the activity increases. Further, if you increase that property, then property will start decreasing. If you further increase the descriptor value, again activity start increasing. So this is like non-linear relationship. So such type of statistics also we have in Canvas. So for example, you have Bayes classification or recursive partitioning or neural network. So these type of statistical methods you would be able to use it. So let me show quickly with the Bayes classification. I would be using again the fingerprint methods here as a descriptor. So it's the same descriptor you would be using, whether it could be molecular property, even it could be fingerprints, right? So only the statistics here we are changing. Okay, so we will go with the Bayes classification. So here, when we are generating model, we put into the bins, we put the molecules into different classes. So it could be based on activity or it could be based on property. So we consider class 1, class 2, class 3. So these classes could be a range of activity. Let's say I have highest active molecule. So above, I have here highest active molecule, which was showing activity like about 8.4 or something. So I will say anything above 7, I will put into first class. In anything with the activity between 6 to 7, I will put into second class. Then anything below activity 3, PIC 56, I will put into class 3. So something like that. So you are classifying molecule, and then you are predicting whether the generated equation is it able to correctly predict the classes of the molecule into class 1, class 2, class 3, or what is the error while predicting the classes. So that is how the categorical model works. So here again, I will go with the activity property. Okay, y variable is activity, and the x variable I will use it. I will use the fingerprint column. Okay, so I will not be using any of the physicochemical descriptors. So now we can go to training set. So here I'll put about 70% of molecule. Oops. Yes. So before we go here, we have to specify the bins, right? So before I go into categories, I have to categorize molecules. Okay. So click on bins here. Sorry. Again, you can go to the options. So in the options, you have bins. Okay. So click on bin. So here you can specify. So how many classes you want to have? Let us say I want to have 3 classes. So then you can click apply. So with the equal width, then it will check for the activity range, whatever property you had specified, or you want to manually change, then that is also possible. So all these options are possible. Okay, so we will go with the default method, equal width. I will go. So it is saying with highest activity there are 7 molecules. Between the activity 6 and 7 there is 7 molecule again, and between 4 to 6 it is having 22 molecules. Like that it has put. Okay, so with that I'll say okay. Now we will go to the training set test set division. So 70% I am putting into training set and 30% into test set. So with that, if I build model, so here it will tell you how many of the classes are corrected or predicted correctly, or how many of the molecules in the training set or test set is going wrong. So it is saying in the training set molecule, from the class 1, all the 16 molecules are predicted correctly. From class 2, there are 3 molecules which are predicted wrongly, and in class 3, all the 5 molecules were predicted correctly. So nothing was predicted wrong. So out of total 23 molecules, only 3 molecules went wrong. That is what it is saying. Okay. So if you see in the test set, again 7 molecules were there total in test set. 3 molecules were predicted wrong. It is saying from class 1 out of 4, 2 molecules, the 4 molecules were predicted correctly, whereas out of 4, 2 molecules were predicted wrongly. That is what it is saying. So in class 2, all the molecules were predicted wrong. So only one was there, that also was predicted wrong. So like that it is shown. So if the prediction correction, the incorrectness of prediction is more, that means the generated model is not good. So again, you can go for training set combination modification, and you can again try to generate the model. So that is how you generate the model. So generated model, again you can apply it. So the same scenario works for all the different types of categorical models. So whether it is a neural network or a Bayes classification, all those things will work in a similar way. Now here, when I was discussing in case of Canvas, so I discussed about various type of descriptors. So we had multiple options. So if it is a topological descriptor or physicochemical descriptor, so many descriptors were there. Then if I have to go with fingerprints, I had 7 options. Again, in the fingerprints, I had multiple options. So then if I had to try out statistics, there were several options in the statistics. So you have to try out, even once you finalize on the statistics, or even once you finalize on the descriptors, till you get a satisfactory equation, you have to keep on trying. So when explaining MLR equation, I explained you, right? So till you get a satisfactory equation, you have to keep on trying by modifying the combination of training set and test set. You have to keep on trying till you get a satisfactory model. You have to try. So instead of going with Canvas, in Schrodinger, in Mastro, we have a fantastic tool called as AutoQSAR. Okay, AutoQSAR. So AutoQSAR is a tool which automatically, okay, how to access AutoQSAR? Let me once again go show you. So you have to go to the task. In task, you have to go to browse. In browse, if you go to the other applications, oops. If you go to the other applications, okay, in the applications related column, you can find AutoQSAR, or you can also type here AutoQSAR. If you type, then you would be able to see the AutoQSAR. Okay, this is how the panel appears. This is how the panel appears. Now, what is the speciality of AutoQSAR? Let us try to understand. So in Canvas, we had to try everything ourselves. So that was the big challenge. So we don't know which descriptor really is suitable, which type of fingerprint, if we are going, is really suitable for our set of molecule, which statistics is really suitable for our set of molecule. That is, understanding that is really difficult, and you have to try out everything, which will take very long time. So here in AutoQSAR, everything is automated. You just feed in the molecule, same 36 molecule I am considering. So you just feed in the molecule, which are the set of molecule and what is that activity property you are looking for, that you have to just specify. The rest, all thing automatically it will do. So it will find out which is the most suitable descriptor, which is the most suitable statistics, all those things it will automatically detect. So you only have to specify whether you have to whether you want to go with the linear statistics or you want to go with the categorical statistics. Okay, so let me show you. So here I have already imported a set of molecule, the same set of molecule, 36 molecule I have run the lick prep for this, and the activity property I have converted into logarithmic scale, and the data is ready now. So this data set I will be using. So you can go to AutoQSAR. Okay, so in the AutoQSAR, the first option is build model. So you go to the build model. So here I am saying the input molecule either from file or from the project table. So generally when we are going for QSAR model, our data set should be really huge. So thousands of molecules should be there. So all those molecule importing is really difficult. So in such cases, you can go with the file and you can browse it. Okay. So if few molecules are there, you can just say from the project table selected entry. Then which is that property which defines the y variable, that is what you have to specify. So y variable is activity. So activity property which I had added, that is what I am going with. I am going with the linear statistics, so I am going with numerical. Okay, so here you are specifying how many molecules you want to put in the training set and test set. That is what you are specifying. So by default 75 is the number. So when I put 75% of the molecule in the training set, so it will say total 36 are there. Out of 36, 27 would be training and 9 would be test set. That is what it is saying. Okay. Then in the advanced option, here you have a choice. Okay, what type of descriptors has to be considered. So it will try out all the different types of binary fingerprints. So radial, linear, dendritic, mole print, or all the canvas topological descriptors it will consider. Or if you want to consider from external source, if you have generated that also you can import. So you can click on property, or you can import file, and from there also you can specify, right? So all those things are possible. So it will explore all the different types of statistics, MLR, PLS, all the types of statistics it will analyze. And with that, you have to just click on run button. Okay, you have to just click on the run button. So since it has to explore many of the things, so it may take around 5 to 10 minutes to generate the model. Okay, for this I have here total 36 molecules. So with the number of molecules, then the time taken also might increase. So for about 35 molecule or 36 molecule, if I have to generate a meaningful model, it is taking around 5 to 6 minutes. Okay, so once the model is generated, so then you, to view the model, you can go to view model and make prediction. So it will appear like this. So initially when you say here, you can it will just list out here. So you can just select it. Okay, or even you can browse and you can specify which is that QSAR model. So whatever model you had generated, with that a folder will be there, and inside that if you go, you would be able to see a QZIP model. So this is AutoQSAR output file. So this you can specify, it is the same thing. Okay, so this is the file I have specified. So here you can click expand. So when it shows initially, when you expand, it will show like this. So there will be overall score, and then it will display you the Q square. Okay, further you want to see all the statistical details, you can say show more, so that all the details it would be able to display here. So here you would be able to see the overall score is calculated based on both R square and Q square. Okay, for training set, test set. So the listing here is in fact, while generating, sorry, I missed out this part. So when you are generating the model, So it will you are saying here how many models you want to save. So 10 models you want to save, you can specify. If you want to save more models, then you can also specify here. So when I was generating the default parameter is 10. So the same thing I had used. So while I was generating the model, so once the model generated, you can see the 10 models, and the ranking of the model would be based on the AutoQSAR score. Okay, so now if you want to see further details, so by seeing the name, you will get the information what type of descriptor it had used and what type of statistics was used here. So you can see it is saying the first model had used radial fingerprints and it used KPLS statistics, kernel based PLS statistics. Okay, so with that you can see the details further. So if you click on the report details, so if you click here, report details, you will get the details of the molecules, which molecule was in training set, which molecule was in test set, what is the since this is a KPLS, so what is the PLS factor considered, how much is the error, which molecule was in training set, test set, and you can even generate the scatter plot. So all these things you would be able to see this in the details. So further you can also visualize the molecules. So in KPLS in Canvas I showed you visualizing model. So same type of model visualization is also possible. Okay, so here you can see, right? So so again here the default color appears. So the positive contributor would be shown with the red color, and the negative contributing molecular fraction or the fragment would be shown with the blue color highlight. So then you can use this for designing the better molecule. So here again you can go with the categorical models also. So automatically it will categorize the training set, test set. So when it is dividing the molecule into training set and test set, it would consider the domain of applicability, all the diverse molecule it will pick up based on structural diversity as well as activity diversity. It will divide the molecule into training set and test set, and it will try out all the different types of descriptor, all the type of statistics it will try, and then it will display you the best model. So that is how the QSAR AutoQSAR works. So just one click button, you would be able to generate all the statistics. So once you generate the statistics, then you can apply the generated model. So here you can specify, so on which molecule you want to apply. So let us say I want to apply it on the molecule which I have imported on the project table. So you can say either project table selected entry or file. So here you can say which model you want to apply. So let's say all the 10 models I want to apply, consensus model I want to consider, then you can go with the first option. You want to consider only one best model, then that is also possible. So on the top scoring model it will consider, or let's say you are not happy with the listing here, you want to consider only few things. So you can select like this, the selected model will get highlighted in yellow color. So you can say the selected models also. So that is also possible. So like this you can apply. When you click run button, it will apply the generated model and it will predict the activity and give us the output. So this is how you can use AutoQSAR. So these are all the things about 1D, 2D QSAR and AutoQSAR. So here I'll stop. Thanks for your patience. If there is any question, I'll be happy to take it.
Thank you, Dr. Pritesh, for the presentation. We have received a couple of questions. As a reminder to all of you, if you have any more questions, please add them to the chat window of the YouTube link and we'll get them added. So the first question is, for such large workload of thousands of molecules, just Maestro on one PC is enough, or more computing resources are required?
The molecule what you can handle in your computer is totally dependent on your hardware's capability. If you have a higher hardware, then the higher quality hardware with more RAM and all, you would be able to handle more number of molecule. So Maestro literally can handle any number of molecule. It's all, the upper limit is coming from your computer's RAM.
Oh, thank you for the answer. Moving on to the second question. There are no tutorials available online for Canvas. Can you please suggest some links?
We will check it. We will try to share with you.
You can just drop us an email on ddcourse@schrodinger.com and we'll share resources with you. The next question is, will there be a demo on using k-means clustering or neural networks?
Neural network works exactly like base classification, the panel and everything is exactly same. So that's why, again, I did not show. K-mean clustering is for molecular clustering. I did not show you that demo. So let me quickly show you. Okay, do you see my screen?
Yes.
Okay, so this is for clustering. So let's say I'm going with, there are four types of clustering methods we have here: hierarchical clustering, lead follower clustering, k-mean clustering. So basically it uses binary fingerprints. So this is nothing to do with 1D, 2D QSAR. That's why I did not include. So fingerprints you can use for various type of comparison. So there are various options again available here. So you can do library enrichment, like hole filling, or library comparison, or similarity distance screening. So all these sort of things you can do, which is not actually QSAR. So I did not cover, that's why I did not cover in this presentation, but I can show you. So I have already generated the fingerprint. So you can just go with the suitable clustering method, and you can specify here the fingerprint column. Okay, and you can specify how many clusters you want. Let's say I am generating some 3 clusters. Okay, 3 clusters. So if I click run, it will generate the cluster, and then I can visualize the cluster. So if I see, so here it will put the number, the cluster number it will show. So here you can see the clustering. You can go to the view, you can right click and you can say view, and you can see from each cluster how many molecules are there. That also you would be able to see here. So that is also possible. 3 clusters you can see here. See here, there are 3 clusters. Oops, sorry. Something happened with my master. Sorry. The master crashed. Hold on a second. Okay. We will take up next question. Till then, I'll reopen and I'll show you again.
Sure. So the next question is, based upon statistics, how can we judge if it's a good model or not? What are the factors to be considered?
Okay, so when you are comparing a statistical model, you have to look for both the statistical parameter generated for both the training set and test set. So as I mentioned yesterday, also Vinod mentioned, so you can really refer his video where he has really spent good amount of time explaining the quality of a model, how to validate the model, and how to check whether the generated model is meaningful or not. Okay, so let me briefly tell you here. So the statistical terms like standard deviation, correlation coefficient, that is R square CV, that is cross-validated R square or correlation coefficient, or F and P, that is variance and probability of error and stability. These are the terms which are calculated for training set molecule. And the terms like Q square, RMSE and Pearson R. These are the 3 terms which are calculated for test set molecule. Now, if you compare the statistics generated, now correlation coefficient R square and Q square. So these are the correlation coefficient which are calculated respectively for both training set as well as test set. So when you compare these two, these should be falling very close. So if you see the correlation for the training set molecule, the correlation between actual activity and predicted activity for the training set molecule, if it is falling 0.9, if for the test set is also falling very close, within 0.3 difference, Okay, then we will say the generated equation is very good. It is correctly able to predict the activity for the test set molecule. So for an acceptable equation, the standard deviation and RMSE. Standard deviation is calculated for training set. RMSE is calculated for test set molecule. These should be close to zero. As small as possible, it should be and close to zero. The correlation coefficient, the R square is calculated for test set and Q square is calculated for training set. These should be close to 1. And the difference between R square and Q square should not be more than 0.3. Then the R square CV, okay, this will tell you R square CV and R square, the Q square CV, this is called as Pearson R. Okay, so these are the statistics which tells you whether the correlation what you are seeing is a true correlation or a chance correlation. So this uses leave one out method or leave 5 out methods, something like that. So even after omitting certain molecule, are you getting the same statistics? That is what you are checking there. So the difference between these, the cross validation and the actual correlation coefficient, again should not be more than 0.25 or 0.3. Then only we will say the generated equation is a good equation.
Thank you. Should I move on to the next question?
Let me quickly show you once the canvas. I could open the canvas.
Okay.
I'm not able to share my screen. Okay, now it is working. Yeah. So I'll just import the molecule. I have already generated, so I'll just show you the model. So here, so if you open the, like in Mastro, we will have project, like same way I have saved the project. And you can see here in the project view, the K-mean clustering. So you can just click on and you can say view. So 3 clusters I had generated. So you can see this is the first cluster. There are 4 molecules in this. And the second cluster, again, there are 15 molecules in this. Okay. And then in the third cluster, we have again 15 molecules. So total in the first total we have 36 molecules. In the first cluster we have 6 molecules. So like this it will generate. Then further you can export it, or you can put it as a filter into the main master view, and you can use it for your analysis. So that is how all these clustering tools work. So these clustering tools would be really useful when you go for final selections of the molecule. So let's say you have gone for the virtual screening and you have shortlisted now 5,000 or 10,000 molecules or something like 1,000 molecules. So from 1,000 molecule, you want to pick 10 molecule or 15 molecule. So you first go for the clustering. So that similar molecule belonging to the similar cluster will be grouped into one category, and from there, out of those groups, you can then pick which is the best molecule. So that's how you can try to pick a diverse molecule from your virtual screening. Yeah. Next question, please.
So the next question is, can we import or export data in CSV or Excel files?
Yes, it is possible.
What to do if we can't find the activity?
Activity is the y variable. So if we don't have y variable, we can't do anything. We have to get the experimental activity done, and then only we would be able to generate any tool. For QSAR says quantitative structure activity relationship, right? So activity is must. So the raw data or initial data set collection is compulsory. We need minimum number of molecules at least to start with some QSAR.
So the next question is about what are these training and test molecules? Our training set, does training set signifies the reference molecules?
Okay, so let me put it this way. I'm generating here some equation, y is equal to mx plus c or whatever, ax plus by is like that, some mathematical equation I'm generating when I'm going for a QSAR model generation, right? So what I'm doing here, I'm representing a molecular structure into some descriptor, some form of number. and then I'm using these numbers to generate a equation. Now, what is the guarantee that whatever the equation I have generated is really efficient in predicting the correct biology activity for an unknown molecule or a given molecule? We have to cross check that, right? So that process is called as validation. So in biology activity, when you are doing, you will take positive control, negative control, right? Blank and standard molecule you will take. So same way here also, we are doing it in a different way. So what we do, let's say I have total of 100 molecules in my collection, for which I have synthesized 100 molecule, and for all the 100 molecule, I have the biology activity reported. Now, while generating the equation, I will not use all of these 100 molecule for which I already know the activity. Rather, I will use only the first, or I will randomly pick some 70 molecules, 70% of the molecule, and I will generate the equation. Okay. Now the generated equation, I will apply on those 30% of the molecule which I did not consider for generating the equation. I will apply this model and I will cross check even for those 30% of the molecule. I know the activity, right? Those are subset of my whatever collection I had. So if my generated model now, which I used like 70% of the molecule which I used for generating the equation, that generated equation, if it is able to correctly predict, if it is able to correctly predict the activity for these 30% of the molecule, which I really did not consider for generating the equation, then I will have a confidence. If it correctly predicts, that means my generated equation is a fantastic one, very good one. If it is wrongly predicting, how much wrongly it is predicting, I will get an idea. Because for these 30% molecule also I have the activity, right? So if it is wrongly predicting, to what extent it is wrongly predicting, all those things I would understand. So that's how I'm validating my generated model. Now this 70% of molecules which I used for generating the equation, this is something like we are training it, right? So that's why we call it as training set molecule. The generated equation from training set molecule, we applied it to test whether it is working fine or not. So those 30% of the molecule, we applied this generated model on those 30% molecule to test it, right? So that is why we call it as test set molecule. So that's how we categorize. That's why we call it as training set and test set molecule.
Right. So the next question is, it's a follow-up question on the Excel. Could you please show how to import, export data in Excel?
File now, so you can just go to Canvas and you can just say import, then it will work. So if you go to Canvas, if you go to file, if you say import, you can select all the different file format. You can see CSV, SMI, Mastro, all the file formats it will be able to do. So that is possible. Okay.
So I think, yes. So the next question is, can we receive a license for live design program along with evaluation license? I don't know if you talked about live design today. So what Dr. Pritesh showed today is Canvas. You will be receiving a license for Canvas along with the evaluation license. For live design, we cannot give a standalone setup for you on your computer. If you are interested in working on live design, you can sign up for the SOC. So in SOC, you receive a login for an instance where you can play around with live design, and you also get to work on a case study that involves the use of live design. So you get your own instance with a demo data. So if you're interested in live design, you can sign up for the Schrodinger online course. Dr. Pritesh, do you want to add to that?
I guess that is fine.
Yeah. I don't know if you talked about live design.
No, I did not talk anything on live design. This is not, in fact, this is not the live design as you mentioned, it is Canvas. So, but if you go to SOC as you mentioned, so there you will get live design glimpse also.
Right. Thank you for answering those questions and the presentation. And thank you all of you for submitting these questions. I have a quick announcement for you. I'll just quickly share my slide. Right. I hope you can see my slide. So the one thing that I want to reiterate is that tomorrow we have a presentation by our industry partner, Glenmark. The presentation is only going to be live, so please make sure that you join us on the JSS channel at 10 a.m. in the morning for the live session. There will be no recording for this session, so you will not be able to see it later. The next is about the office hours. So today we have office hours from 4:30 p.m. to 5:30 p.m. If you have any questions related to anything, it could be a technical question, it could be a scientific query, it could be something related to this course, it could be our licensing, it could be our hardware. So anything, if you have any questions that you are facing issue with, we can assist you during these office hours. Please make sure that you join through the Zoom link that is provided on our website page of this event, which is schrodinger.com/dd course. So please visit this website page and you will see the link how to join the Zoom session for the office hours, and also there will be a password, so make sure that you copy both those things. It is the same link that you'll be using for any future working hours. So please make sure that you save this link. It will anyway be there on the website page for now. The next is if you are interested in the SOC, which is Schrodinger online course, the next session starts on November 2nd. The registrations are open right now. The registration end date is October 26th. So please make sure that you register and pay. So you have to register and pay before October 26th. If you do not have the discount codes, you just write to us and we'll send you the discount codes. On using the discount code, you will avail the special discounted price of $125 as opposed to $350 and $475. That is the regular price for students and non-students. So the discounted price of $125 is only available this year. There are no more sessions after this November 2nd to December 9th, the session. After this, there are no more sessions in this year. So please make sure that you attend this one if you want to use the discount code and if interested in this course. The other thing is after we have sent you some of the emails that we did not have details of your HOD, of your guide and stuff like that. So if you have filled the evaluation request form again, we are reviewing those and we'll be sending out emails to you how to install and what to send us. If there is any other, if I have not contacted you saying that your license was approved or not approved and you haven't received any communication from us, please make sure that you write to us at ddcourse@schrodinger.com, and we'll make sure that your response has been taken and it's been recorded for us. So the next thing is about the certificate. Some of you are asking about the certificate. So at the end of this course, we will be giving you an assessment. Upon clearing or qualifying the assessment, you will be receiving an e-certificate. So that for that, please make sure that you are registered for this course. I think that's all from my end. If you haven't already registered on our website and requested a website account, please do so in order to get any resources, the training material, the videos, the seminars, in order to download our software and to avail the Schrodinger online course. You need to have this account. Please make sure that you go to this link, which is schrodinger.com/request account. If you haven't done so, please do so now. I think that's all from my end. I'll see if there are some
Sylvia?
questions.
Yeah, there are a couple of questions that came in.
Okay, great. So there are some questions. Okay, so I'll take up the license validity question. So the license will be valid for 1 month upon you receive the license. So how the license validity works is the dates are hard coded in the license. So when you receive the license start from that date. So you cannot, it doesn't mean that it's a 1 month license. Once you install it, starts for 1 month. The license will start from the date we send you the license. The next question is about the presentation for Dr. Pritesh. The question is, okay, the question is changing the substituent and predict the activity. Is it only in AutoQSAR?
You can do it in all the methods. So everywhere I showed you, right, how to apply the generated model. So you have to generate. So if you're going individually with the canvas, then you have to first generate the descriptors for these imported molecule, the designed molecule. Then you can apply the model. There is a in the main option you have apply generated model is there. There it will predict. In AutoQSAR, there is a direct option. You have already observed. So that is how you can apply.
Thank you, Dr. Pritesh, for the answer. And thank you all the panelists, Dr. Kaushik, for helping us with the questions, and all of you for joining us today and submitting your questions. Please make sure that you attend tomorrow's session live. We have an exciting session, an exciting talk by our industry partner, Glenmark Pharmaceutical. So please attend it live at 10 a.m. tomorrow. So that's all from my end. Thank you for joining us, and have a great day. Bye-bye.